Yes, so we planned this out beforehand. So the idea was that Ken would be talking about the roles and the importance of these critters, and then I would be talking about potentially how to, what their habitat needs are, how to design habitat for them in your landscape, and particularly given the theme of this workshop, thinking about how to turn lands that are maybe not fully they're not realizing the potential on your land, on your farm, so wasted lands, lands that aren't really doing anything, how to turn that into habitat for beneficial insects. I think after Ken's presentation, I should definitely put another quote under the beneficial, because I totally love his deconstruction of the idea of a pest. So, anyways, talking about wasted land here, I'm thinking about lands that are, again, not realizing the full potential. They're maybe field margins along fence rows and ditches, along riparian areas, like kind of wet areas or steep areas that are harder to farm. And these areas are just kind of sitting there. They're often forgotten. They're not really, they're neglected. And so, what can we do in terms of creating habitat for the critters that Ken was talking about? And disclaimer, I'll be mostly talking about pollinators and pest suppressors. So that's two of the types that Ken was mentioning and their habitat needs, and there's the whole range of them there. But I should also mention that a lot of the things that I'll be talking about will also benefit, like the decomposers and the herbivorous insects and some of the other species as well. So I love that holistic view. I'm just, in the short time, I can only talk about so much. And so starting with what do these guys need? Well, just like us, food, water, and shelter is the best place to start when you're thinking about creating habitat for anything. So for food, I'm going to be talking about an abundance of diverse flowers, which is required for both pollinators, which pollinate the nectar, and a lot of the pest suppressors, which are also pollinators and are also omnivores, so they pollinate nectar as well as pests. Some of the more carnivorous pest suppressors need other non-pest insects during times when the pests aren't having an outbreak to sustain them throughout the year. They require water as well, and they require shelter, both for nesting and overwintering, and shelter from pesticides and other elements in the environment. And just to kind of think about this, you can't have these different habitat elements scattered across a giant property. They need to be kind of within the same sort of area so that they can, because all these guys have different foraging distances that they're willing to travel to get their different habitat needs covered. And I'm just saying for right now, work has been done with bees a lot. The median foraging range of bees, all of these native species that we're talking about, is around 150 meters. Some of the bigger ones, like the bumblebees, will fly much more than that, but some of the really tiny ones that are still very important will fly less than that. So the median range is 150, and we're still trying to figure that out for a lot of the pest suppressors out there, how far they're going to travel. But it's also, it can't be too, this stuff can't be too spread out. So what do I mean by food? Abundance of diverse flowers. Well, I'm talking about diverse flowering species with different shapes, sizes, colors, and bloom periods. So different, these insects are attracted to different colors. Bees tend to be, for example, attracted to lots of purples and yellows. And they have different flight heights, and some bees can access very deep, complex flowers, like clovers, whereas other bees and other, like for example, hoverflies require much more shallow, open flowers like yarrow or something like that. So getting a whole bunch of different shapes in there kind of gets your bases covered. And bloom periods is particularly important to consider. It was kind of alluded to by Ken there. Why do we need diverse bloom periods? Well, this is a nice little chart that shows the different, this is just bee genre across Alberta, some of the main ones. And then here is the months through the season. And we have, in this yellow bar here, is the blooming period of canola. So if you only have canola in the landscape, you have no food for all these bees for the rest of their flight period lives throughout the season. And so trying to get that covered throughout the season is very important, and is done by having a diversity of flowering species in your system. And so this is a chart of all the different flowering periods of different native trees and shrubs. In Alberta, so you start in the early season with trembling aspen, white birch, balsam poplar, and moving in towards near the end with Irish cranberry, snowberry, meadow sweet, those sorts of things. I should note that this chart is just trees and shrubs, and it's actually missing herbaceous species, which is a really important element to consider as well, like wildflowers, which are like things like goldenrod, fireweed, like smooth aster and other asters. Near the end of the season, the trees and shrubs are kind of tapering off, so including some of those wildflowers is important to get them enough food before winter. Clumping flowering species together is another good principle to follow. Bees especially display something called flower constancy, so they'll go out from their nest and they'll forage around and they'll stick to the same species of flower. And so if you have those species kind of clumped together, it just makes it that much more easy for them and they can be more efficient foragers. Native flowering species are preferred. So studies have shown, well, first of all, most of the beneficial insects we're talking about here are native. Like we're talking about all those native species of bees and stuff. There are exceptions, but most are native, and they have adapted and preferred native plants and stuff. So plants that have evolved with them through evolutionary time periods. Native plants are also, they're more likely to provide habitat for alternative sources of prey to keep the pest suppressors going when the pest outbreaks aren't happening, and they're less likely to provide habitat in general for crop pests. So unlike the beneficials, a lot of crop pests are not native. They came when we brought our crops in from like Europe or wherever we brought our crops in from. They specialize in those crops. For example, the cabbage maggot came over in around the 19th century from Europe with the brassicas and stuff, and is now rampant across the prairies here. And so if you have native species, you're going to kind of tip the balance towards the native beneficials and less towards the pests, if that makes sense. So. And this has been shown in multiple studies, which I don't have time to go through. Water, another important fact to consider. I mean, when you're designing habitat, you usually don't have to actually like put in water features or anything like that. Usually these insects are pretty resourceful at finding like dew or muddy patches or things like that. However, during droughts and things like that, that can be a limiting factor for these insects, and climate change and that effects on droughts have been kind of linked to bumblebee ranges and stuff. So something to consider as well. So in terms of shelter, so nesting and overwintering sites, again, Kim kind of alluded to this a bit. A lot of bees will nest in the ground. They'll burrow little holes and lay their eggs one after the other, and then they'll hatch. So having undisturbed areas of soil, bare soil. Some bees will nest in the hollow stems of plants, like raspberry or elderberry, and will hang out there. Basically, there's a whole bunch of different kind of nesting sites. What we're looking for in general here is a little bit of habitat complexity. So three-dimensionality to your habitat rather than a single flat area, having, again, differing heights and decaying woody bits that you don't try to clear out every year because some insects will burrow into those in the winter. And rock piles, anything that provides a little bit of shelter from the elements is what will be used for nests and overwintering sites. And another example, bumblebees bumblebees will form little colonies in abandoned rodent burrows or underneath bunch grasses or piles of rocks or something like that. And then protection from pesticides and the elements. So in general, if you can create wider habitats, they're just more resilient to pesticide drift and weed encroachment from the adjacent lands. Coniferous species can be used intelligently to reduce pesticide drift. They're really thick and they're resistant to a lot of the herbicides. Not completely, but they help. And they also kind of reduce wind speed and contract snow and increase the moisture in the habitat. Although they shouldn't be planted, they should be planted so they don't shade out the habitat, because you want a lot of sun to encourage flower growth. And in general, a lot of the foraging species prefer the sun. So how can you design some of this habitat in some of the wasted areas in your property, the neglected lands of your property? Well, the first thing to consider is to think about what you already have and begin to notice what you already have and protect that existing habitat. And in this particular case, one of these pictures just so happens to have some pretty good species already going for it. So I'm going to just blow this up. This particular field margin, this unassuming ditch here has some gaillardia, has some purple prairie clover, and some other, some goldenrod in there and stuff. It's got some native species going for it, and it's got the potential to already have some good habitat for beneficials. So noticing and protecting that existing habitat is the first step. All right, I should say that this is maybe not a complete, perfect habitat, but it's a start. And so once you do that, connecting from that habitat and building up from there. So as you start to design this habitat by planting diverse flowers and species and planting trees and shrubs to add that habitat complexity, your habitat will only be colonized if the beneficials can travel to it, and they'll be able to travel to it much better if you connect it to existing habitat. And then final thing, or to kind of keep in mind this, is that I was kind of mentioning that the median foraging range is about 150 meters, all right? So for a lot of these critters, they won't be able to travel super far into fields. And so that's important to consider because a lot of our fields in farmland are much bigger than that across. So that, if it was 150 meters, that would imply that every 300 meters you've got to have some sort of habitat for the majority of species to be able to access into the inner places of the field. And so because they're a lot bigger than that, it would imply that to create this habitat, you'd actually have to take land out of production. If you have a quarter section devoted to canola, and 800 meters across, the beneficials aren't otherwise going to get in there. And that might be a bit of a tough sell for farmers. It's like, you're asking me to take land out of production to create habitat for if the majority of these beneficials are going to occur in the fields, and much more difficult sell than just turning your field margins to habitat. However, there have been increasing studies in the last few years to show that taking land out of production, in this case up to 8%, and it could have been more, this was their highest one that they tried, with the rotation, it was a similar rotation what you see here. It was rapeseed, which is essentially canola, wheats, and field beans, and converting that into beneficial insect habitat, it actually increased overall yields over 6 years, even given the land that was taken out of production. And so, if we take the findings of this study seriously, then one could argue that keeping land, an entire large field of land in production of a single monoculture crop, could actually lead to not all of that land realizing its full potential, basically, or compromising that full potential. Implying that perhaps that some of that land, or so there's wasted areas in lands that might otherwise be, might otherwise seem to be at first glance fully productive.